Hello everybody, nice to see all of you. This is the first time I have been presenting on such a huge screen, so it's the first time for me. My name is Alexander Rockvan, and I am going to talk about the project I've been working for a couple of months now in the Netherlands. My project subject was Hadoop, so I'm going to tell you first about my project and how does Hadoop fit into that. I'm Alexander Rockvan, as said, 23 years old or young, it's just how you put it. I'm a third year student of the HZ University of Applied Sciences in the Netherlands. Worked for 6 months on this project, the last semester actually. This project, I did this with an agile work style, and that means you develop 2 weeks with your stakeholders and you discuss everything you do in that. And I also used the CRISP DM cycle. I'm not going to touch the CRISP DM cycle right now in this presentation. If you want to know more about the CRISP DM cycle, please come to me and I can tell you all about it. I've been working with visiting data from entrepreneurs, and with visiting data I mean numbers of visitors on hotels, campings, restaurants, and that kind of stuff. Those are I got the data from from several regions in the Netherlands, Belgium, France, and United Kingdom, and that makes it also a European project, and that's why there's a European Union flag under here. So that's for that. My problem question that I got from a couple of entrepreneurs is the following. Which market segments are visiting our region during good and which during bad weather? For my research, I focus only on the entrepreneurs in the Netherlands, because then the source of the data is very close to you, so you can discuss it easily. You can get more data if you want to, and it's just if it's a bit closer to home, it's easier to discuss stuff. And also another question that I am talking about are the numbers of visitors being influenced during the events in the region. Which steps did I take? Well, I inventoried anonymous data from Zealand entrepreneurs, and if I say anonymous data, that's a bit abstract, because what is anonymous data? Well, entrepreneurs are saving data, are collecting data about their bookers, about their visitors, with names, email addresses, birth dates. You cannot imagine what they all save into that into their data sets, and I'm not allowed to see that, because the university says, yeah, you can use the data, but not all the data. So the university anonymized the data for me, so they removed the names, they removed the birth dates. It's only actually the booking data. Is there a customer on what day, and what did he book on that day? I inventoried regional and national events in the Netherlands. Basically that's not very abstract, it's easy to know. I've been working with the Royal Dutch Meteorological Institute, the weather data for that, and they were surprised to see that students were so interested in getting data from weather, because it's as you will see in my presentation, there's a huge research center for the weather data in the Netherlands, but they don't do a combination, as you will see here, with marketing segments or visiting numbers in the regions. An important step that you will see in my presentation is a definition of weather in percentage. Well, you know, I'm not going to talk about it now. I will show you in a while. Also, a step that I take, and it's also a hint of Arne. He said, I was talking about my project. He said, yeah, what you're doing is imputing. So I searched it and I said, okay, now I know actually what imputing is. And yeah, it's really close to indeed imputing. I'm going to talk about that in a while. So this is actually imputing, as you will see it in a diagram. If booking data, let's discuss it first a little bit easier. To know which customer or how many customers there are on a date, you need actually a simple date and a number of visitors. But if there's only an arrival date and a departure date, you don't have a hard date to say, okay, this is the date where the tourist visited our company. So you need a kind of an algorithm to calculate that. And as you will see in my presentation also a little bit further, that the data set is not always the same. Some companies have an arrival date but no departure date. Some companies have only overnight and departure dates and that kind of stuff. So this is actually a diagram of how do you can use that knowledge of imputing to know, okay, is this data, can we use it for further analysis, or is it not? Is there no analysis possible at this point, and does the entrepreneur need to give us more data? These are actually the results of the imputing. So you will see, for example, Camping de Pekelingen, that has a couple of numbers. There are dates, the actual dates with the visiting numbers. This is the test data that I made easily in a text file, actually. And the Camping de Pekelingen is a real data from the entrepreneur self. Data of Zealand. In the background you see the region Zealand, and you see a couple of entrepreneurs here. They are very famous in Zealand, but I guess when you're in Finland you won't know the name, so that's okay. This is rather important. We have, each entrepreneur had 100,000 entries of visitor data. 15 companies were actually analyzable, so we could use the data, and 3 were not usable. And that's because some of the data was missing and we cannot analyze if there's no booking data or arrival or departure date. This is a table that I made to create insight in the data. What you actually see is on the left hand side you see the name of an entrepreneur, and the first column is the arrival date. Is there an arrival date in the data set? Is there a departure date in the data set? Are there stayovers? Are there numbers of visitors actually in the data set? And is there a bookings date? Why do we need this kind of table? Well, it's easy now to see, okay, which entrepreneur can we use for our data set and which do not fit our requirements for a suitable data set. And you see that, for example, now I need to pronounce it in Dutch, of course, attractions, you see a historic museum, and a sailing school, and the sailing school does not have the arrival date or departure date. Actually, it has nothing. So that's easy to say, okay, we cannot use that. To go a little bit deeper, let's say for each entrepreneur on what date the data set starts, on what day it ends, how many rules there are in the entries there are in the data set, and the frequency. So is it per booking, or is it really per date? So that that there are really that it's really written. Okay, on this day there were 10 or 20 or 30 visitors. It's here in the yeah, you will see it here in the table. The events we have in the Netherlands. You see here Easter. Those are these are the national events. Easter, Sinterklaas. It's a real famous event in the Netherlands on 5 December, and of course Christmas on the end of December. These are the local events that have a major impact on the visiting data. Concert at Sea is one of the major events you will see in Zealand when you are visiting there at some point. As said, this doesn't look very good, but I'm going to say what it has to be. As said, I use weather data to analyze and to show, okay, is there a correlation, or is there a match between the visitors data and the weather data? What I have here is the data of the Royal Dutch Meteorological Institute, of the KNMI, and in a few words we can say that a day has a good on a day there's good weather or bad weather, and actually there are a couple of factors you need to have there, and it says there maximal 0.2 millimeter of rain in 24 hours, above average temperature, and the average is normal 14.5 degrees, and a minimum of 50% of the day if the sun can shine, it shines. And the average temperature here, I based it on the average temperature of September. You will see here two graphs actually of the weather in September. On the left-hand side, you see the weather in September 2015, the temperature, rain, and the sun, and in the next is in September 2016. Bookings data, I did a lot of inventorization there, and why did I do that? Well, basically you want to do data science, and at least there was a reason to do data science, because there was a lot of data, and many people said you cannot do the research. Many people said to me you cannot do the research because you're missing data, or all the data is different, and that kind of stuff. Well, I just got a quote and just said it a couple of times to a couple of stakeholders. I said, get all the reasons why it won't work and believe the reason why it will, because at some point you will see a match. Of course, it has to be a logical match. I can make a match of ice cream sales and wind in the average speed of a wind, but that has no logical sense. So it has to have logical sense. Also, data scientist is of course the sexiest job on the planet, and most of the important quote on this page, I think, is the goal is to turn data into information, and information into insight, and that's basically what we are trying to do here. So with that in mind, I think you all agree that this isn't very that this doesn't give you very much of an insight. You see all entrepreneurs, and that's basically it. You see all the entrepreneurs, and you see when the weather was good or bad, but that's it. If you give this to a stakeholder, he'll say, go back to a drawing board and make something that I can understand. So let's do that. we have a couple of testing areas, and this is a graph of one of the testing areas. What I didn't tell you yet is that the gray bars you see on the background is the weather variable. So I said, we need to know if there was a day that was good weather or bad weather. And you see the spikes on the background. 1/3 is okay if one of the three variables was met. You see 2/3 if two of the variables were met, and you'll see a big spike if all the variables were matched, and then we are speaking about good weather. Why do I want to show you also the 1/3 and 2/3? It gives a lot of more insight to see when there's not that kind of good weather. It could, for example, rain in the night for like 1 or 2 millimeters, say 5 millimeters. Then you have a bad day, according to the algorithm. But if the sun shines on the whole day, then it's for the entrepreneur a good day. So you have to have a kind of a way in the middle here. This is also a testing area. You see the visiting data with the spikes of the nice weather. You see most of the time where there's bad weather, you see a dip or low point in the visiting data, and if there's a lot of good weather, you see a spike. This is most of the time it's camping, so they hire accommodation for a couple of days, and you will see that also in let's say August and September. You see that the weather isn't always that good, but it keeps steady. And in July, one of the busiest months actually in Zealand, there's a 2 minutes. 2 minutes. I will hurry. So this is actually all the data. If you want to see it or if you want to know more, please come to me and I will show you some of the data. This is the entrepreneur data. These are the events with the visiting data. Basically, so how do we continue? We share the knowledge, of course, of all the data. We try to use machine learning, and the next question that we're trying to answer is what is the predicted number of visitors in the region of the basis of market segmentation and weather forecasts. So how does Hadoop fit into this? Well, it's a framework to store and process large data sets. It's good, scalable. But I want to talk with you about MapReduce, and I will skip this one because this one doesn't give very much insight. Let's say this. There's a couple of scenarios. If you want to know how many words there are in a book, you can give each student 4 hours to read the whole book and count the words. Then you can say, okay, the majority has said 45 words, and you lost 4 hours. But if you do it like this, each student has a chapter of its own, counts the words for 1 hour, and then you get the same result within less of time, 1 hour and 1 minute. And that's called mapping and reducing, and this is how it's used actually inside Hadoop. So how can we use Hadoop and Hadoop MapReduce? Well, we can read more data from entrepreneurs, of course, because we have more power. Improve the way that data is being sent. We can analyze data on the first hand, and we can then say, okay, this is suitable for us, or this is not analyzable at all. We can automate some processes like anonymizing data, and we can make data sets to create forecasts so that we get an answer on our previous said question. If you want to follow me on GitHub, it's possible, github.com/AlexanderRockfan, and rest me nothing else than to thank you for your attention and to ask if there are any questions.
Thank you. insight of real data and real work with data, and that's very valuable, and this is what you guys should strive to, and see the practical issues that you might encounter, like when we discussed about the missing data, and I just gave you the keywords to look forward. That is just how everything evolves. Ask questions. An interesting remark was about data scientist. Yes, it is probably the sexiest job in the world, but the new occupation has emerged, and that is the guy in between. So somebody who can discuss with data scientists and decision makers. And that new work or occupation is called data translator. So you need to have the skills to understand the processes, but you also have to have the skills to understand what these guys with data and the stuff are doing. So it's very important. This graph on MapReduce was really intriguing. I've never seen that before, but that's exactly what MapReduce is all about. And MapReduce is an integral part of Hadoop. Another thing that you should reflect as well is if you consider the neural networks, the different layers are alike. They are not directly similar, but you do different processing between the layers in deep learning. So it's not anymore as complicated as it used to be, because we have enough data today. And that will also lead you to really interesting results later on when you expose your data to machine learning platforms. And this is out of the scope of this course, but like I said previously, it's an integral part of working with data. Because if we are comfortable with statistics, it's like driving your car with only the rear view mirror for you. So then you just guess what happens in front of you when you see what happens behind of you. But with the processing of data, machine learning, data fusion and such, then you'll get the opportunity to predict what will happen. And eventually, hopefully, your windscreen is open in the future. So thank you again.
Thank you.
Next one, please.
Tässä on näkyvillä.
Käykö homma?
Käypi.
Katsotaan tässä, kuinka käy. Yllättyykö se? Tuleeko se nosto?
Ei tarvitse. Okay, I'm Jarno Kaunisto.
Anna, mä olen Timo Salmalainen.
Christina is on work-related trip, and she's not at Finland at the moment, so we're doing this by ourselves. But she contributed quite much. Also this. So, Apache Sparks and Spark streaming. This is what we started when we decided that how we approach the item, and we divided this to the 3 parts mostly. And mostly we use it internet, Google to start with, and a lot of reading.
Okay, and what are Apache Spark benefits? And I want to say it's open source platform. 1 million free code, and you can use it your own project for that. And it is fast platform. It's well 100 times powerful what MapReduce must be. And it is unit platform on data management. You can use many languages and maybe Spark SQL, Spark Streaming, MATLib, or like that stuff. And it's an interactive console also, and it's a graphical interface when you see it. And it's also benefit of the API and Hadoop and that like non-SQL databases. Typically, we have a lot of information in the beginning, and we streaming data like YouTube or you use it flight radar data and analyze the data to that kind and in the 2B.
And here is a little comparison between Sparks and Hadoop. And most of this information can be found quite easily from the internet, so I won't read it everything, but I think that the biggest difference is that Sparks tries to use the memory more than hard disk, which makes it little bit faster. But it can also use hard disk for processing.
And yes, it's need some kind of input data streams like Kafka, Bloom, and or Hadoop and that kind, and it's analyzing and it comes to output streaming that data.
So we tried to find what was the minimum requirements where you can set up the Spark system, but clear minimum settings cannot be found. At least I didn't find anything where I would say that this is the minimum value. But these are the suggestions value, so that, for example, memory, 70%, 75% should be given to Sparks and rest for the operating system, and of course, more the memory, the better it works. And but it can be installed in quite smaller system also. But about the benchmarking information, there's a petabyte sorting kind of challenge in the web. Here's the web address if you want to Google, and there's a task that sorting 100 terabytes of data as fast as possible. Previous record was made by MapReduce with 2,100 nodes and 50,000 plus cores and 72 minutes. Sparks made same, sorting the 100 terabytes of data in 23 minutes, less nodes, less cores. The more details you can find from the webs if you just Google petabyte and Sparks, probably quite easily found. We installed Sparks in the virtual box. I will show you that in a minute. And the setup that we gave for the VirtualBox was 4 GB of memory, 4 cores, 20 GB of hard disk, Ubuntu, because mostly processing is done in background, so graphical user interface isn't that important. And then we installed OpenJDK because it requires Java, and we put one master node and one slave node in there. Well, first we had kind of similar to petabyte sorting, that we had 1 GB of ASCII file, but we do kind of sorting in there. But then we were able to do live streaming from the live.flightradar24.com website. I show you details a little bit. And we direct that information from the web to the local netcat port, and then with another Python code using Spark, we do a word count on it. And we also use a little bit terminal grep command to filter unwanted information out. The word count script comes with the Sparks as an example code, but getting the data from web, we had to do a little bit our own works. And a little bit background for the. So this is the website where we get the data. This is Helsinki, Espoo, and South Finland, and as you can see, the planes are moving. It's live data from about us, and you can see there's a different information. If you get this page all the time, you don't get the actual flight data, because it uses a little bit different request, and it returns the value in JSON. So this is kind of information that you will get. And for example, here you can see that where the flight, I don't remember exactly, is it where it came or where it's going, the flight, but apparently in New York JFK airport. And so here we have the virtual site. We have a script. We start the Spark processes, and then we have this. This is the script that will fetch every second the flight data from web. And then we have another script here, another terminal. I can show you a little bit. So that it will run this network word count 2.python script, localhost port 9999, and grep everything that starts with these 2 characters. And so, and here you can see that the last number in here is the how many times that word was mentioned in the collected data, and this will print out same data that was visible in the website. Example, hell was mentioned 15 times now, meaning Helsinki airport. Finn was mentioned. But this does it. This was the fastest what we were able to do in the given time. And our time starts to be done.
Okay, so data must be analyzed and take into what you want in the data.
Yeah. And conclusion about Spark is that it is a powerful tool for data processing, open source. It can use streaming because every minute, example, United States is spilling several terabytes of data every minute. So streaming will be more and more important in the future. And one huge benefit is that Spark can be connected to other tools. And since it's open source, usually means that it's developed fast. Example, 2 years ago, 2 years old documents mentioned only Scala and Python, and at the moment it says Scala, Python, R, and Java as a tool. So supporting.
And also develop it also in the time.
Thank you.
Thank you. Any questions?
Good.
Okay, Spark is, if I remember correctly, at least it was one of the first streaming platforms for big data because of the slowness of MapReduce for rapid response. It's still there.
Yeah.
Se menee suoraan. Ai eikö ei.
En ole aikaisemmin kokeillutkaan tätä. No.
Okei, nyt sen tulee.
Pistän kohta. Se näkyy. Okay, hello everyone. So, it was nice about the Spark, but we have a little bit better one, Blink. Yeah. I can tell you a little bit later why. So, what is Apache Flink? It's a community-driven open source framework for distributed big data analysis. And original research project was Stratosphere, and it was launched about 2008, I remember. And joined to the Apache incubator beginning of 2014, and graduated as an Apache top-level project was late 2040. It's a project that evolved the concept of multipurpose big data analytics framework, and hybrid engine. Actually, it's only one hybrid engine in there. It uses real-time streaming and batch streaming also, both. Yeah, this major contributor to the movement of unification of streaming and batch, and it's a fourth generation of big data analytics framework. The first one was this Apache Hadoop, and second one was Apache TEDS, and third one was this Apache Spark. Yeah, Apache Flink original vision was getting best solution from two technologies, and those was MPP database. It's a massively parallel processing database, and other one was Apache Hadoop. So from MPP it was declarative query optimization and efficient parallel in memory and out of core algorithms. And from Apache Hadoop, massive scale out it, user-defined functions and complex data types, and of course semi-on-read. And they put those together and add more this real-time streaming, iterations, memory management, and advanced data flows, and of course general APIs. So we had a plan to put this Flink to the cloud, but we didn't get it to work. So we like to compare this Flink with this Hadoop and Spark, and you can see this very nice animation here. So we have this data processing engine. We compare this and speed, optimization, tool, catching, and requirements. Yeah. The data processing was this batch processing with this Hadoop and Spark, but this Flink used this stream processing engine. And speed, Hadoop is quite slow, and surprised Spark was almost 100 times faster than Hadoop because it's a in-memory processing system. And Link is even more faster because it's a underlying streaming engine. Optimization, it's manually in Hadoop and Spark, and in the Blink it is automatically optimized. And scheduler, only this Hadoop needs external scheduler like a UCI, but Spark has its own, and Blink also have own, but it can also use this scheduler called YAM. Don't ask nothing about that because I didn't get any information of that, but I heard there's that kind of also. And the caching, Hadoop doesn't catch the data in memory, but Spark and Apache Flink does. And these recovery events, Hadoop can handle path processing and Spark near real-time processing. And this Blink real-time processing. Amazing. But then we think that we have to show you something about this stream processing. Yeah, many applications continuously receive large streams of live data, process them and provide results in real time. And stream processing is the processing of data in motion. And a moment, I have something more in here. Yeah, in other words, coupling on data directly as it is produced or received. The majority of data are born as continuous streams, and from sensor events, user activity on websites, financial trades, and so on. And all these create a great series of events over time. And before there was a streaming processing, the application or sensors send data flow to database or file system or other form of mass storage, and after that application would query the data from the databases. But with this streaming processing, it can be in the whole way from the beginning of the end to pick this data. Well, yeah, thanks. It was short, but
Thank you. Any questions?
what is YAM?
Okay, what you need to remember is that these are not necessarily separate tools. So, like Hadoop, you shouldn't consider Hadoop as a Hadoop.conf or Hadoop.txt. It's a set of different tools and frameworks. And that yarn that you mentioned, it's yet another resource negotiator, which means that when you distribute the data and processing, then you need some kind of a resource negotiator that is this accessible, is that accessible, how do you deploy that, and so on. So it's kind of an organization. There are some interesting tools for controlling the whole setup of big data, but we didn't discuss about that during our course because it's another story. Just like how I ruled out everything concerning machine learning and others, we just don't have enough time for that. So if this course had taken like 1 year, it would have been totally another question. But that's why you have separate courses for different things. Now the major difference here between these really streaming tools and Spark is that Spark is micro-batched. So Hadoop is batched naturally. So you collect a batch to be processed and then you do your job, like MapReduce. But then you split in other platforms, like in Spark, you split it into not microscopic but small batches, and then it kind of mimics the streaming. But Fling is a good example of real streaming. Another one is, of course, Storm, and then, like you guys mentioned, that this is a hybrid tool, just like Apache Beam. Unfortunately, I think we don't have any presentations on Apache Beam, which is the latest, which came out of incubation in the beginning of last year. But this is just how things evolve, and something to take home from all this is that keep in your mind that everything changes, and it changes on a monthly basis. So keep your eyes open and learn new things and others as well. So thank you.
Would you like to take a break at this time? Okay. 10 minutes. Kyllä sä voit jättää sen tänne, me voidaan laittaa se valmiiksi ja pääset suoraan. Puuttuu.
Niin, laittaa se pisäkkiä.
No niin, mitä kun sinä nyt?
Meillä meni vähän eksperimentiksi.
Tästä sä saat, ellei sulla ole suoraan HD. Onko sulla HD?
On tää tosi.
Joo, ota sit toi palikka irti. Anna mä. Se olisi varmaan tule tähän istumaan. You mean refresh the page?
No, I mean like now I can edit my report because I have seen report yesterday, but today I have changed it to show you can see
You don't have your own laptop.
I have my laptop there.
Okay, you can use that for
No,
presentation.
I mean like if I can give you my new version of report.
Okay, I'll open the page.
Yeah.
Ja se vielä tuntuu. Otan kaikki tuossa.
Joo, tässä on. No, voitais katsoa sitä jossain vaiheessa, jos saat sille esimerkiksi. Mä oon yrittänyt kysyä, että mä haluaisin, että mulla olisi ottaa talleen sitä pitää olkaa. Niin suuri. Yksi valokuvaaja rupesi kuvaamaan sitä. Se ilmeisesti niitä skriiniä. Hiljaisella nopeudella se kuvaa sitä skriiniä. Mutta se on oikeasti tyyppeitä. Siinäkin olisi yksi sellainen paikka, jos saisi niin kuin auttaista sen videoviivan sisällä, missä just nämä turvasysteemit. Esimerkiksi manuaalinen on digitaalinen, sitä ei näkyisi sillä kun auto on liikkeessä. Se varmaan 10 kilsaa tunnissa nyt sillä, mutta mitä siis ne on aivan hysteerisiä siinä, mistä tulee. Toni just kertoi sitä että tuossa mulla on se XC90, niin kukaan ei ole onnistunut kuolemaan sisällä. Sitten mä näin ihan kolarivideossa, se oli Ranskassa ajaa tommosella, niin ohjaajat päättää Citicase vitosta. Tuosta tuli etupyörä linksahtanut, siitä oli ripustukset ja muut poikki. Se aivan lunnastuskunnasta. Se pistää kanssa vähän vastuuta kuskille, jos sä lähdet sekasta jollain. Älä nyt alkaa pienempiä sanoa tossa. Mene vaan rauhassa. Mikäs teidän päättötöiden tilanne on? Mikä teidän päättötöiden tilanne on?
Ei ole oistustakaan.
Täältä voisi löytyä aiheita, jos vaan kiinnostaa. Haastetaso voi valita itse.
Mulla on työnantajan vähän liittyvä aihe, niin vaikkei se nyt suoraan tähän liitykään, mutta aina sitten sille, jos se työnantaja maksaa palkkaa, niin
Ja sitten ei kannata ajatella sillä, että kuka on niin se ohjaava opettaja. Todennäköisesti mä en teidän töitä edes ohjaamaan. Tulkaa silti kysymään, jos te olette sitä mieltä, että joku näistä kurssilla esitetyistä idiksistä sopisi teidän siihen työhön. Niin kyllä mielellään, niin kuin tässä esimerkiksi mä sitä Aleksanderia autoa, kun hän vähän tuli juttelemaan.
Me puhuttiin tuossa luokassa, niin kun sä tulit, tää on nyt aika laaja alue, että sehän nyt aika paljon liikkuu. Ja tuolla jo niin kuin, näitä työkaluja on aika paljon tässä nähtäisi. Ja sitten on myöskin näitä terveellisiä.
Kyllä. Niin, mutta jokainen aloittaa jostain. Ja sillä tavalla, että se on niin kuin etu, että te olette päässeet kuitenkin jollain tavalla katettuun pöytään tässä. Et tällä hetkellä se on ehkä niin kuin tämmöinen, tämän tekoälyn kanssa on sellainen tilanne, että siellä ei ole ehkä ihan kaikkia kamoja vielä löyty tiskiin. Ja sama oli tuossa 10 vuotta sitten Hadoopin kanssa, niin oli sitä javajumppaa, se oli todella rupista puhua. Sitä mä just tuossa yritin sanoa, että kaikki muuttuu suurin piirtein kuukauden viiveellä. Mutta jos me ajatellaan peruskaluja, mikä tässäkin on tullut jo esille, Python, R, muuta kyllä ne siellä vaan koko ajan on. Ja tuskin tulee katoamaan. Ja sitten jos me ajatellaan vaikka tätä tekoälyskeneä, niin mikäpä muu kuin Python luettaa sen.
Tomi on tehnyt jo.
Se on tehnyt jo.
No sillä on pistetty jo kasassa.
Okei.
Ja meistä vielä on vanha, kun se niin, Ruotsia ei ollut vielä silloin kun se edellinen, kun siinä on ne tietyt ajat milloin saa on se siinä seuraavassa keväällä Onko toi mitään pitopäivää?
No niin joo, just juteltiin sen kanssa, että ei ole sen, saiko se pistet niinku siitä
Ruotsista?
päättötöistä?
En tiedä.
Okei, se pitäisi.
Joo.
Mulla pitäisi olla fyysinen osuus valmis tässä kuussa. Kirjoitus on kesällä. Osaa laittaa vasta tänään. Sitten mulla on ollut ne 3 viikkoa. Kuukausi. Aika rientää. Just tässä. Pistäänkö Aatre sulle tuo finaaliversio tuosta?
Pistä vaan.
Toikin lähettää varmaan sähköpostilla toi.
Okay, I'll open the web page so that you can re-upload
Okay, thanks.
your stuff there.
Yeah, I was going to ask you that.
Only one per group, so you don't upload.
Jos toi nyt ei toimi.
We wait for our
Ah, yeah.
ending.
Tuleeko toi?
Minä en jo vaikka
Eikö siitä?
Mikä se näistä? Meillä. HDMI. Miten tää toimii?
Sitä saa voimalla painaa.
And please don't block the view of the camera.
Go. Okay, so we had a bus storm, and we went on this bit differently. But there's few things that storm is good with. So it's very fault tolerant, and it's easily scalable, and it's fast, and it supports multiple languages. And how it works is that the data stream comes to the spout, like a text stream, and the spout does what you want it to do. So, for example, it cuts the streams into words. And then it moves it to the POLT, and the pod, every pod has its own jobs, so to speak. So if I want to know how many times a certain word is in a stream, I give the specs to the pod, and it processes the data and moves it along to another pod that counts how many times it happens. And this is used a lot in like error logs and log processing logs, and it's used with Twitter. And Twitter is actually the main. It's pretty much made for Twitter, and Twitter platform is very intertwined with this. So we wanted to go with try to figure out how to what are the most common used words in Twitter feeds, and we thought it was gonna be rather easy, but that didn't happen. So we were gonna remove the all common words like I and in and do and so on, and count the words that were the other words, and with that try to get the most used words. And Juha tried to do the installation, and he's gonna tell more about it.
Okay, I tried to get hands dirty and do something experimental, like getting data and sorting it like Storm UI. And well, we started with Docker, and then we installation of the Storm, and then we installed Maven. We did Java path because it needs to Java. And then we tried to test topology test, and there was it should be easy, but something went wrong. This is also when we tried to Windows. What?
Yeah, on Windows Docker, we got it pretty much up and running, but it wouldn't take any data. So there was something was off.
Is it that class not found exception that you got frequently?
Pretty much.
Okay. How about the environment variables?
Yeah, we this is the Edu Cloud installation, so I'm not sure it. Yeah. Conclusion.
Yes. So we this was what happened several times, and we tried. How we started with this, we were not very familiar with it at all, actually. So we had to start from pretty much zero level, and first fighting with the Java installation and the Java paths, and then with Docker. So in the end, last night, very, very late, we decided that this was our final result.
Yeah, but someone can do this. So here is some user cases who are really using the Storm, and as you can read, VeriSign uses Apache Storm for security purposes and mitigating cyber attacks, and Cerner uses Apache Storm to improve patient safety, among other things, and Navisite uses Storm to process server logs to find anomalies. So this is few examples how to use Storm, but if you can, you can.
There was also in that installation which hadn't mentioned it. It also needs Nimbus and Zookeeper to get that Storm UI works.
And also a few that maybe a bit more familiar is Twitter uses it, but also Spotify uses for suggestions and for that Storm. So maybe a bit more familiar platforms. But this is
That's true. But some examples how to use.
thank you.
Thank you.
Okay, thank you. You guys might remember that, you might remember that I warned you about the Java and its complexity in this environment, and especially when we discuss about distributed Java. You have to be really confident with Java. And since this course is not about Java, and we don't actually, at least that I know of, we don't deliver such elaborate Java courses that are prerequisite. But it's not the fault of Java, it's just when you build up some system, you have to have a robust platform on which to build. And Java is really good. It's the best solution for such an open source environment that we enjoy with the Apache approach. The same is with Microsoft. So if you intend to install Microsoft tools, it's not enough that you just install some of the versions of Microsoft operating systems. You have to install, in most cases, what would be a simple one? Just to put up an Exchange server. You don't just install Exchange server because it has its prerequisites. You need to install this, and in order, like a SQL server. Okay, but in order to install SQL server, you need to install something else. So it's a stack of installations, just like what you guys now encountered there. I've been struggling with the environment variables, and this class not found exception is quite familiar to me, because you really need to tune your environment variables and test the paths and debug over and over again. It's really tedious operation. Another one would be that if I gave you guys a ready-made platform, then you couldn't ever know the torture behind all. Seriously, just use it, and okay, fine, it works. It's quite straightforward in its operations. But, okay. You are welcome to try.
Hello, good evening everyone. My name is Sagar Aryan.
My name is Kamal Lakal.
I'm Sudarshan. And we have done a project when we create an application and we to get data from the Twitter by using Apache Flume. So firstly so this is how our application works. Like we're gonna pull data from Twitter, and we have installed Ardo, and we have configured Flume where Flume send data from Twitter. It pulls data from the Twitter and send to Ardo, which works as a centralized data store. So firstly, so this is the outline of what we're gonna explain here in our presentation. Description, situation and challenges, Flume architecture, nodes, Twitter, and how this installation process, and finally conclusion and result. So I'm gonna describe some of the topics. So first, let's start with the description about Apache Flume. So what is Apache Flume? It is an open source data collection which transfer data from source to destination. It is highly reliable, distributed and configurable tool for effectively collecting, aggregating and transferring large amount of streaming data, for example like log data, events, etc. From various sources like, for example, social medias like Twitter, Facebook and email messages to a centralized data source. There are a lot of advantages about why people mainly choose Apache Flumes for streaming data. So here is some of the few points like why people try to use this environment with RDoF. So it helps to stream data, like it ingests a lot of data from multiple sources and sent to multiple destinations. Insulate system, like it has a guaranteed data delivery and this can horizontally.
Okay, we are constantly talking about data, big data, and continuous streaming data. There are trillions of billions of data that are streaming, that are generated every day. So now we have some challenges right now. So we have data sources and we have sinks, and we want to channel those from source to sink, and we want to create that in such a way that it continuously streams data from source to sink. And for example, we have some camera and we have some computer, and then we could take photos from camera, and then we have some computer to restore those photos. But we want to do something that, live from camera to computer. It goes continuously streaming in the same way, and that's whatever data is. Because data is generated from the sources, and we want to sync those data into the sink, and then we want to have that channel in between. For example, this channel in between. And what's that solution? That solution is Apache Flume. So my colleague already discussed about what is Apache Flume. It has Apache Flume is just a channel in between the source and sink, so that we could dispose data from web server to the SDFS. Mainly Flume is composed of an agent, a source, and a sink. So the agent is the most important part of the Apache Flume. So what is agent, for example? An agent is something. For example, we could take in real life scenario an agent as a USB cable, for example. USB cable, for example, we connect it to the computer and we connect to the phone. For example, from the computer, the data are generated and the wire is just a channel, and then from the sink, the data are fetched into the phone, for example. Here we consider the data is just from the data, computer is a source and the phone is a sink, for example. It could be vice versa. So this is what explains all about it. So we get a lot of data from the web server, and then we want to store, and these are HTTP data, and we want to store those into the Hadoop system, that is the HDFS system. So, and this Apache Flume acts as a channel in between these two systems. So this is mainly the architecture. For example, we have in the real life scenario, we have lots of clouds, and we have lots of social networks, Facebook and Twitter, many web servers, news, and many things which are generating a lot of data, and then those log data, for example, okay, I want to mention about log data as well. So what is log data, for example? So log data is nothing but, for example, every entry that we put into the browser that are stored in the logs is a log data, and then those log data are processed by Flume, and they're entered into the SDFS system, and as we can see in the pictures. So this picture describes about the nodes of the Apache Flume. So talking about Apache Flume, it can have lots of nodes to process the data. For example, it can be single layer, it can be single node or multi-node Apache Flume system. In our application, we have tried to make a single node Flume system, but here we can see that data are generated, and then you can see the flows in the flows. They process in parallel way, so that the data is reliable. Data is it could be processed in a best possible way, and then this data to have some scalability and reliability as well. And then those are stored in event, and they are stored into the sink. So now here we have developed an application so that we could pull data from Twitter to Sync. So here we have used the Hadoop and we have installed Hadoop, and then we have installed Flume, and then we have fetched data to Twitter, and then we have sent data to the HF system. So my friend is going to explain all about this.
Okay, thank you. So this is how we first have to have this Twitter application. So we can just put our information here, and then it creates our tokens and everything like this. So what we can do is just like after this, I have just some pictures here for now, but I will show you the demo how we plan to do it and how it went. So now here is this one, that is how we configure the Hadoops and these things, and this is what the tokens that we get from Twitter application. We have to put in a config file inside this Flume, so that it takes all those tokens and the keywords there, like here I have written like Jordan, Finland, Espoo, Flume, something. So it extracts the data from the Twitter which has those keywords, so it can be live streamed to the server. So this is the example, and this is the log files, and that is the overview how it looks. But this is how it must be look like Twitter data and the change in data. But the main thing here is like we try to do it in EduCloud, like inside the Metropolia's network. As the earlier presentation faced some difficulties, we also face some difficulties there, that it doesn't allow us to connect to the local host. Instead, it's blocking us to go from there. So I have asked question in OMA about that, but nobody answered that. So we then decided to do this in Ubuntu. It was yesterday. So I will show you like here a small demo. Like here we don't have Ubuntu, so that's the problem. So now I am connected to my home's Ubuntu system from here using VNC viewer. So this is what I have done like overnight today, like this, and then we try to do something and show how we can do it. So here is my home's Ubuntu. And then okay, it's not there. Okay. Is it frozen or what? Now it's not showing here now. Yeah, thank you. Yeah. Okay, so this is what I'm running from my home and the terminal. So what we could do is just like, first of all, we need this Hadoop Java things to run this. So it's a little bit complicated because this Ubuntu has its own system, and rewriting over there it shows so much conflict again, and I need to create some user into that, but that didn't work either. So what we got is like, okay, so first we have to be inside the Hadoop now here, and then we have to run the SDFS so that okay, so if we start this, then so this is what we had the problem in the Metropolia server, like it didn't allow us to go inside. So here it is like connecting to the Hadoop server, and then it takes some time, yeah. And then as we discussed before about this AND also, like it helps in resolving the data there. So we just It's okay. It start in. So it starts. Then now we are inside Hadoop. So this is how we can be inside the Hadoop. So after we run these things, and then now what we did, this is the part of the Hadoop. So now we go to the Flume. So it's a little bit complicated because in order to run the Flume, we need to have the Hadoop. So we are doing like two parts of things at the same time. So now, okay, so let's go to Flume home. So now we are inside the Flume. So here what we can do is now, as I said before, like in the Twitter config file, we have given all the information, and we need to run one command so that it takes the Twitter file. Like here, like inside the bin file, there is this flume ng and its agent, and then config file. So there is a config file called Twitter config, which we have placed all the tokens there. And this is how it must show, like it must show in the console and in the Hadoop website. But when we do this, it blocks after this. I don't know why. It didn't allow us to go further. And it says that SLF4J conflict, and I tried to find it so much, and then there was no outcome. But it didn't give the Twitter data, but it gives the folder so that we could see something like it's streaming. So if we go to the web browser here, so here like in this Hadoop's local host, we are able to run till this one, but it would be like, this is the Hadoop's overview, and then it gives like version and everything, and inside this utilities and browse the file system. It's a little bit slow because due to the connection maybe. Yeah, so here like I have this Flume there and the user. So if you go to Flume, no, maybe inside the user. Yeah, there is this Hadoop file, and then inside the Hadoop, you can see like there is this Twitter data and the SecGen data. So I have created these folders like and given the path for them in Flume, and it's showing the folder, but the size and this block size is 0. So that means the data is not coming, but the folder is coming. So it's somehow working, but I don't know what went wrong, and maybe the Java things, or we couldn't figure out this like how it's. But at least we were able to connect Hadoop, Apache, and Twitter together, so that it somehow gives the folder, but it didn't give. But we were able to find the log files. So here is the log files created by Apache. So here, suppose if you go here, not this one, but maybe this one. No. Yeah, so yeah, I don't know where the error is, but it is showing all the things and everything is running from there. But when you go down, it gives the log files, but I don't know, for somehow, and it gives all the Java path, and there is this Java version, and it's running inside a secondary name host is also running and local host, but I don't know, for some reason there is no Twitter data. So yeah, this is what we did and what we come. So we just want to present like what we came through. So maybe in the future, for our own experience, we could go further into this. But it was good experience. Okay, thank you.
Thank you.
Any questions?
A comment. I tried to tell you all guys that you should consider the container. You
Yeah.
can get the container for Hadoop, and you can get the container for all of these fellows to make them communicate with one another. It should be easier, but at least with the installation that we have But CentOS 7 is notorious for its security enhanced Linux. That's why we actually killed all the security settings because of it's an internal server, but you should never do that at home.
Yeah.
I have, for example, I've done the CentOS with the Docker with this our virtual LAMP environment as well. For example, all the Hadoop installation is pretty much done, and then it's pretty much things there. But then when I connect to the ports, there the ports are blocked.
It asks for the password localhost
That's
something.
interesting. It should be there should be some kind of a testing or debugging scene for you. So it's quite complicated, as you can see, that
Yeah.
where to break this all.
Yeah.
Mm-hmm.
And even in the Hadoop environment, for example, the Flume is pretty much done and Hadoop is pretty much done, and then everything is pretty much done. But when I connect to the Mozilla, for example, everything is pretty much processed in the terminal. But then when I connect it to the browser, the ports are pretty much locked, and then it doesn't really access.
It's hard to say.
Yeah.
But it was a good experience.
For our demo, I googled and first I did it so that I was planning that I will use top, which gives local statistics all the time, and then I directed that to Netcat, and then I would use Spark to read that Netcat site.
Okay.
And if you can get the Twitter information coming to your site, then you could probably directed that to Netcat and local port, and then use the Flume.
Yeah, I have done with the Netcat also, because I tried with this Twitter data and then SecGen, and after that I found one presentation of the Netcat. We did the same configuration, but then it didn't somehow work for. Maybe we did something wrong in the configuration or something somewhere.
It's more than likely that something goes wrong. It's of course, it's always the order of everything, and especially dangerous it is when you install two environments with Java. They
Yeah.
might have some kind of an installment of another version of
Config,
Java,
yeah.
and then you have a
Yeah,
flash.
but before I tried with Java about 1.7, and then when I run this Flume, then it says that you have to have the newer version of Java. So and then I again downloaded 1.8, and the error that shows before is different than the error that is showing now. So it's kind of really difficult, like which one to do, then how it goes, because it's the big system and we are trying to do in one.
And you always have to remember, that with Python. So whether you have Python 2 or Python 3,
Yeah.
and the code is different.
Yeah.
So be really careful with that one. It's kind of an irritating situation.
But I think this Docker could be the answer. For example, pulling the Hadoop, for example, pulling the Hadoop repository, and then putting the Flume repository, and we somehow this Docker are pretty much independent. I emailed the Docker team actually, and then they didn't reply clearly, but then
Yes,
I think that could be much easier. For example, whenever there are different containers for everything, and then if we could link them independently, then it doesn't really mess up the system as well. Yeah.
Okay,
Yeah.
thank you.
Thank
And
you.
are we in the last one of the presentation?
There is one.
Yes, I know.
Yeah.
That is the last, I think.
Thank you.
Okei. Laita mulle viestiä, että näitä.
Okay, so my project was Apache Apex. My introduction is that I tell about this presentation my research question, methods, results, and then last conclusion. So My research question was what is Apache Apex and how to use it, and my method was to research about what is Apache Apex and what is used for, and then implement Apache Apex development environment in practice. So Apache Apex is Hadoop Yarn native big data processing platform. And what is Yarn? That it is an operation system of Hadoop that is responsible for managing and monitoring workloads. It makes it possible to allow multiple data processing engines such as real-time streaming and batch processing to handle data stored on a single platform. So Apex enables real-time stream as well as batch processing for big data. Apex is designed to process data in motion in a distributed, highly performant, fault-tolerant way. And Apex consists of two primary components that are Apex Core and Apex Malhar. And this Apex Core works as an engine responsible for resources, bookkeeping, checkpointing, fault tolerance, scalability, and etc. And Malhar is a library that contains the functional building blocks to help users to build their applications. So when executing applications, the platform handles all the details, includes dynamic scaling, state checkpointing and recovery, processing guarantees, etc. It allows focusing on writing applications, logic without mixing operation and functional concerns. And some important concepts in development of Apache applications are packages, operators, autometrics, and custom control tuples. And these application packages are zip files that contain all the necessary files to launch an application in Apache Apex. And this is standard way for assembling and sharing Apex application. And operators are basic building blocks of an application built to run on Apex platform. And there are three types of operators based on functions, and these are input adapter, generic operator, and output adapter. And autometrics are used to collect different kind of statistical information about a process, which can be very helpful and useful for diagnosis. Custom control tuples are used to give the user support and capability to insert user-defined control tuples in the data flow. So then I tell how I implemented the Apache Apex development environment. So first I had to install some development tools to set up a development environment for creating applications that run on the Apex platform. And these development tools were Git, Java JDK, and Apache Maven. And Git is a reversion control system. Java JDK includes the Java runtime environment as well as the Java compiler and variety of tools. And Apache Maven is pull system for Java project. And here I have already installed all the tools. So after installing and configuration these development tools, I could now use the Maven archetype to create basic Apache Apex project. And to create new project, I executed the following lines. Now, after that, I was able to see new directory named my Apex containing a Maven project for building a basic Apache Apex application. So next, I created the application package file in my Apex app directory, and then I run unit test to see if Apex was working correct, and it was, and you can see it was success. And so then I built the Apex core and Apex Malhar repositories with the following commands, and they took some while, as you can see. It took for 7 minutes, and so after this I had now complete the implementation of the Apache Apex development environment, and here's a picture of Apex Malhar library, and you can see some functional building blocks there to help users to build their applications. So in conclusion, Apache Apex is Hadoop YAR native big data processing platform that enables real-time stream as well as batch processing for big data. And it is consists of two primary components that are Apex Core and Apex Malhar. And Apex provides a stable base of fault tolerance, low latency and scalability. It is easy framework for the developers to be productive. Thank you.
Thank you. Now you got kind of a spectrum of different tools to pick up from and to analyze. So if you check the different Apache tools that are available, then dig a bit deeper into those. Now you have some ideas, you have learned about the different problems that people have encountered. Don't be disappointed. It's just life. And like I tried to tell you guys that when I first installed Hadoop, it took like ages to install it. Next time it went smoother, and after like 20 installations, it was quite straightforward. But I had a lot of different scripts and such, which I developed along with. But that's just how you keep up a productive system. You just have to work on it. Even
at one point you feel like giving up, okay, I don't want to do this.
Yes. But then just take a cup of coffee and take a walk and get back to it. Okay, thank you guys. This was it. I hope you enjoyed as much as I did. And I hope that you really have something to take home with you from this course. And later, if you have ideas, please share it with me and the rest of them. Okay, happy holidays.
Yeah, thank you.
Before I go, I wanted to show you something. What I thought was really handy if you use, for example, Python. I thought another student told me because I have Python to work on. And you can make an alias in, for example, Mac. So here I see the Python version that gives me 2.0.10. I have an alias for one project. And I just then say automatically it has the Python version, and the nice thing is it has already the recommended imports. Right. So here I, for example, say import or use the packages for